Hi, Software Engineering Lecture 2. In this lecture, Software Engineering Principles, the need of software engineering, characteristics of good software, software process, and what are the costs of software engineering. Recap first of Lecture 1. Software is more than just a program code. A program is an executable code which shares some computational purpose. Software is considered to be a collection of executable program code, associated libraries, and documentation. Software, when made for a specific requirement, is called a software product. Engineering, on the other hand, it is all about developing product using well-defined scientific principles and methods. So we can define software engineering as an engineering branch associated with the development of software products using well-defined scientific principles, methods, and procedures. The outcome of software engineering is an efficient and reliable software product. Wear and deterioration. The software does not wear out. Hardware components suffer from the growing effects of many uh, other environmental factors. When a hardware component wear, it is replaced by the spare parts. This is also called a bathtub curve. It is applicable only for hardware. These may be caused by extreme usage, excessive temperature, dust, vibration, high voltage, etc. As more time passes, at one time the hardware becomes unusable. This is called the wear out. Software deteriorates, it is in infant state. Software has a high failure rate, but after customization and repairing the defect, it becomes an idealized state. Software defects may happen due to unfulfilled user demands, slow, bugs, and many more. Here is the ideal curve showing the idealized state. The actual curve shows the increased failure rate gradually due to the change during software customization and modification. So the software does not wear out, it is just deterioration. Software engineering principles. Software engineering principles use two important techniques to reduce problem complexity: abstraction, and the second is decomposition. The principle of abstraction implies that a problem can be simplified by omitting irrelevant detail by considering only those aspects of problem that are relevant for a certain purpose. Once the simpler problem is solved, then the omitted details can be taken into consideration to solve the next level abstraction, and so on. So decomposition is a powerful way of reducing the complexity of the problem. In these techniques, a complex problem is divided into several smaller problems, and then smaller problems are solved one by one. And then the solution of different components can be combined to get the full solution. The need for software engineering arises because of the higher rate of change in user requirement and the environment on which the software is working. Large software. It is easy to build a wall than a house or building. Likewise, as the size of software becomes large, engineering has to step in to give it a scientific process. Scalability. If the software process were not based on scientific and engineering concepts, it would be easier to recreate new software than to scale an existing one. Cost. As hardware industry has shown its skill and huge manufacturing has lowered down the price of computer and electronic hardware. However, the cost of software remain high if the proper process is not adopted. Dynamic nature. The always growing and adapting nature of software hugely depends upon the environment in which the user works. If the nature of software is always changing, new enhancements need to be done in the existing one. Quality management. Better process of a software product provides better and quality software product. Characteristics of a good computer software. Software product can be judged by what is offered and how well it can be used. This software must satisfy on the following grounds: operational, transition, and the third one is maintenance or revision. Operational characteristics. Operational characteristics of a good quality software product are based on the functionality and related to the exterior quality of the software product. Various operational characteristics of a quality software products are as follow. Correctness. The developed software product make sure should meet all the customer specification. Usability or learnability. The software product must be user friendly and easy to understand even for IT illiterate end user. Integrity. Like each medicine has a side effects. In the same way, software may have a side effects. It may affect the working of another application. So good quality software should have no side effects. Reliability. Software should not have any defect. Not only this, it should not run time fail. Efficiency. The efficiency factor of a quality software relates to the effective use of the available resources by the software product. Security. To keep data secure from external threats, good software products have high security factors. Safety. The software should not be hazardous to the environment and or end user life. Revision characteristics. Review characteristics of a good quality software product based on the engineering factor that relates to the interior quality of the developed software. The factor of the software quality deal with the efficiency, documentation, and structure of the software product. Various revision characteristics of a software are as follow. Maintainability. After delivering the software product to the end user, maintenance should be easy for any kind of end user. Flexibility. As per the end user's requirement, product changes should be easy to make. Extensibility. For future functionality enhancement, software products should be easy to increase the functions performed by it. Scalability. Developed software products should be very easy to upgrade for more work and or more number of users. Testability. Testing the software should be easy. Modularity. Every software is a collection of separate programs, units and modules that are dependent and are independent for each other. If the software is divided into separate independent parts that can be modified and tested separately, it has high modularity. Transaction characteristics. Transaction characteristics of a good quality software product based on the data intervention behavior factor that relates to the software end user environment and platform. Models, usability and interoperability of the software. Various transaction characteristics of softwares are as follow. Interoperability. Interoperability is the ability of software to exchange information with other applications and make use of information transparently. Reusability. If we can use the software code with some other modification for different purpose, then we call software to be reusable. Portability. The factor of software refer to how well the software can adapt to changes in its environment and our platform or with its requirements. A software process is a set of activities and associated result which produce a software product. Four fundamental process activities are common to all software processes. These are requirement specification, design and implementation, validation, evaluation. Software specification where customers and engineer define the software to be produced and the constraint on its operation. Software development where the software is designed and programmed. Software validation where the software is checked to ensure that it is what the customer requires. Software evaluation where the software is modified to adapt it to change customer and market requirement. Types. A simplified representation of the software process presented from a specific perspective. Example of process perspectives are a workflow model. This shows the sequence of activity in the process along with their input, output and dependency. The activities in this model represent human action. A data flow or activity model. This represents the process as a set of activities, each of which carries out some data transformation. It shows how the input to the process such as specification, it transforms to an output such as design. The activities here may represent transformation carried out by people or by the computer. A role action model. This represents the role of the people involved in the software process and the activities for which they are responsible. What are the costs of software engineering? There is so simple answer in this question at the distribution of cross the different activities in the software process depend on the process used and the type of software that is being uh, developed. These are waterfall approach, iterative approach, component based approach and develop and evaluation cost. So let's see. In the waterfall approach, the cost of specification, design, implementation and integration and testing are measured separately. Notice that system is integrated and testing is more expensive. Develop activity. Normally this is about 40 of the total development cost, but for the some critical system it is likely to be at the at least 50% of the system development. Iterative approach. If the software developed using an iterative approach, there is no hard line between specification, design and development. Specification costs are reduced because only a high level specification is produced before development in this approach. Specification, design, implementation, integration and testing are carried out in a parallel within a development activity. Component based. Component based software engineering has only been widely used for a short time. They don't have accurate figure of for the cost of different software development activities in this approach. However, we know that development cost reduced relative to the integrative and the testing costs are increased because you have to ensure the component that are used meet the requirement specification and work as expected with other components. Development and evaluation cost. On the top of development costs are also occurred in changing the software after it has gone into use. The cost of evaluation vary dramatically depending on the type of system, such as command and control system that may be used for 10 years or more. However, the smaller business system have a much shorter lifetime or consequently reduce evaluation cost. Thank you.